Happy morning, students. I hope you all are safe and home. So in this video we are going to discuss about the topic impact of elastic bodies. It's one of the important topic in engineering mechanics. So in fourth unit, dynamics of particle, we have this topic. So impact, the collision between two bodies is said to be impact. During impact, the colliding bodies exert the relative large force called impulsive force on each other. On impact, body deforms first and then recover due to elastic property. So we have two masses which traveling with the initial velocity is going to impact with each other. During impact is going to deform. So this deformation is an elastic deformation. The two bodies is going to recover due to its elastic property. So after this, due to the impulsive force, is going to move in different direction with different velocity. So the types of impact. Impact generally classified into two types, the central and eccentric. These two again classified into two categories, which is direct and oblique impact. So we are going to discuss about this direct and oblique, how we are going to differ this to the central and eccentric and direct and oblique. So central impact. Central impact means the center of two masses which lies in a same line. That is central impact. Again, the central impact is divided into direct central impact and oblique central impact. Direct central impact means the velocity of two masses is parallel to the line of action. It means the direction of motion of these two bodies, it should be parallel to the line of impact, means it's a direct central impact. Now come to the oblique central impact. The velocity of two masses is inclined with the line of impact. That is, direction of motion of two masses is inclined with the line of impact. It's called oblique central impact. Eccentric impact. Eccentric impact means the center of masses which have offset from each other, it not lies in the same line, it has an opposite distance. That is eccentric impact. Again, the eccentric impact is classified into two types, direct eccentric and oblique eccentric. In direct eccentric, the velocity of two masses should be parallel to the line of impact. So that is direct eccentric impact. The direction of motion of the two masses should be parallel to the line of impact. Now come to the oblique. So the direction of motion of the two masses is not parallel to the line of impact, so it is inclined. So it is oblique eccentric impact. Eccentric means the center of mass of the two body which is offset from each other, that is eccentric. So period of collision. Period of collision consists of two time interval. One is period of deformation and period of restitution. So when two masses travel with different velocities, it's going to collide with each other. Initially it get contact with each other, then it undergoes a deformation. So the time elapsed between the instant of initial contact and the maximum deformation is called period of deformation. The duration between the contact of a body and the maximum deformation is called period of deformation. Then period of restitution means after deformation, due to its elastic property, two masses is going to recover its initial shape. Then the impulse force is going to separate the two masses. So the time elapsed between maximum deformation and the instant of separation is called time of restitution. So we are going to use this two. By using this two parameter, we are going to find the final velocity of a masses. Okay. Then we have two principle, which is coefficient of restitution and conservation conservation of momentum. By using this two principle, we are going to find this final velocity. So let's consider two masses with m1 and m2, which is the masses of a first and second body, which moving in the velocity of u1 and u2, so initial velocity of the body. So it's going to impact with each other. So after impact, the velocity of a two masses is going to change, that is v1 and v2. So this v1 and v2 is the final velocity of a first and second body after collision. So during collision, we know that the two masses is going to undergo a deformation and separation. So during deformation, Fd, it will be the force acting during the period of deformation, and Fd into dt. dt means the duration of a period of deformation, that is dt. So the product of force and the period of deformation is called impulse during deformation. Then after deformation, the two masses is going to separate from each other, that is a restitution. So F4, it will be the force acting during the period of restitution. Then the product of F4 and dt is the impulse during the restitution. Let E will be the coefficient of restitution. So by using this coefficient of restitution and conservation of momentum, we are going to solve the problems. So by using this two parameter, so we can form an equation, which is the coefficient of restitution is the ratio between the impulse during the restitution and impulse during the deformation. It can be rewritten in terms of a relative velocity, that is E is equal to relative velocity of separation by relative velocity of approach. The conservation of momentum. Conservation of momentum means the momentum before collision is equal to momentum after collision. What is momentum? Momentum is a product of mass and the velocity. So before collision, we have a mass m1 and m2. The initial velocity of the two masses is u1 and u2. So the momentum before collision is m1 u1 plus m2 u2. So this is the momentum of two masses before collision, which is equal to momentum of two masses after collision. So after collision, the velocity of the two masses is going to change, which is v1 and v2. So the momentum will be m1 into v1 plus m2 into v2. So this is the conservation of momentum. So in terms of weight, it's going to rewrite the equation in terms of weight. So weight w1 by g u1 plus w2 by g into u2 is equal to w1 by g into v1 plus w2 by g into v2. This g is acceleration due to gravity. Let's solve the problem. So this is a question given. The direct central impact occurs between a 300 Newton body moving to right with a velocity of 6 meter per second and 150 Newton body moving to the left with a velocity of 10 meter per second. Find the velocity of each body after impact if the coefficient of restitution is 0.8. So this is the data given in the question. So we have a mass 300 Newton body, 150 Newton body, and its velocity is 6 meter per second towards right, 10 meter per second towards left. Then we are going to find the final velocity of a two body after impact. We don't know the direction and the magnitude of the v1 and v2. So we are going to assume that if the two masses is traveling in a same direction. Then by using conservation of momentum and coefficient of restitution, we are going to solve this. We are going to find the v1 and v2. First, the conservation of momentum. We know the conservation of momentum, which is momentum of two bodies before impact is equal to momentum of two bodies after impact. So momentum, we have this equation w1 v1 plus w2 u2 which is equal to W1 V1 plus W2 V2. So we are going to substitute those values. We know the W1 and W2, U1 and U2. So we are going to substitute those values over here. 300 into 6, 150 into minus 10. So the negative sign, which indicates the direction of motion. The second mass is moving towards left, so we are putting negative sign over there. So we don't know the V1 and V2, so we are going to substitute the W1 and W2 alone over here. So we can simplify this equation over here, which is 2V1 plus V2, which is equal to 2. Make it as the equation 1. Then go to the coefficient of restitution. We know that E is equal to E into U1 minus U2, which is equal to V2 minus V1. That is, coefficient of restitution is equal to the ratio of the relative velocity in separation and the relative velocity in approach. So we know the initial velocity of two bodies, U1 and U2, which is 6 and 10 meter per second, and the coefficient of restitution is given in the question, which is 0.8. By substituting that, we can get the second equation, which is V2 minus V1 equal to 12.8. Now, by using these two equations, by solving these two equations, we can find the V1 and V2. So we got the V1, which is minus 3.6 meter per second. So this negative sign indicates that the mass 1 is moving towards left. V2 is 9.2 meter, so it is in positive. So mass 2 is moving towards right. Thank you, students.